Well, finally, Meta has launched their Llama 3.1 family of models, and this time they have also launched their 405 billion model, which is their flagship model, and according to some claims, it competes or sometimes even outperforms the 3.5 Sonnet model, GPT-4o mini model in some benchmarks. That is a very big claim, and we'll be seeing the benchmarks and all of it. So let's see what is the key capabilities that they have introduced. Here you can see tool use is something they have introduced, complex reasoning and coding assistance. About the tool use, if we head over to their blog, and here you can see this actually shows you the capability of the tool use. So let's watch this video from the start. Have a look. Here you can see a CSV file was uploaded and the model was asked to explain it, and it explains the data type of the model. Now the user asks, can you plot a time series? And you can see the model runs a code, generates a plot and shows the time series. Now the user is asking, can you plot the S&P 500 over time in the same graph? And here you can see the model is responding to it. So it works like code interpreter in my opinion. So this is something new in the 3.1 model family. So let's move on and see what else do we have with these new models. If we directly head over to the benchmarks, this here is something which is actually interesting. At the right section we can see the top 3 models, and in MMLU chat here we can see GPT-4o mini performs the best, but if we come to IEF evaluation, it is instruction following, how well the model follows the instructions. Llama 3.1 beats both the GPT-4 mini and the Sonnet model, and other than that, in the reasoning arc challenge, it outperforms the Sonnet model and the GPT-4o model. And in some tool use models, it outperforms both the models. And also in long context test, it significantly outperforms both the models. So we'll be checking how it actually performs in long context tests. So stay tuned for that. Also in the multilingual MGSM test, it is on par with the Sonnet model. And if you head over to the GSM 8K test, here you can see it scores 96.8, but something which you should note is this is in 8-shot chain of thought prompting, but the Sonnet model does 96.4 in 0-shot. So that is something we should take into consideration. So this is all that we have from the Llama family, but there is something more. I was very disappointed with the context length that we got in the Llama 3 models, which was 8000 tokens, and for me it was not usable. So I was fascinated about the context length. So if you head over to the Grok website, here you can actually, if you head over to the Grok cloud and head over to documentation and models, here you can see the Llama 3.1 family is listed, and here the context window is mentioned, which is 131k tokens, which is absolutely the most important update according to my opinion, other than the 405 billion model obviously. So this actually makes these models usable. So having a look at these benchmarks and all of these claims, it is nice that this 405 billion model is performing very nicely. If we head over to the 70 billion model, you can see in most of the cases it beats out the GPT 3.5 turbo model, except in the tool use in BFCL. And in my opinion, we should not compare to the GPT 3.5 turbo model, because GPT-4o mini is even cheaper than the turbo model. So comparing it to the mini model would be something that would have been nice. But if we move on to the 8 billion model, that is Llama 3.1 8 billion model, it completely destroys the Gemma 2 9 billion model, falling short of just the ARC challenge, where there is a significant difference. Other than that, in the MMLU chat you can see it scored 73 and Gemma 9 billion scored 72, but without chain of thought prompting. So that is something we should take into consideration. Now given all of these are benchmarks, and these are curated, and we know how these things work. So we will be actually testing all these three models with our LLM rubric, and we'll be actually checking out how it performs. If you want to check out how these models actually perform in real world tests and reasoning, check this video out at the top right corner. Thank you guys for watching.